life on another planet.
The best proof yet.
K2-18b
could be home to life.
NASA just confirmed it. A planet 40 light-years away shows biosignatures with 99.7% certainty. But here's the terrifying part. It's orbiting a star that died 3 billion years ago. The James Webb detected oxygen, methane, and something else. A synthetic signal, repeating every 4.3 hours. If life evolved after stellar death, what intelligence is sending that message? The discovery came 3 weeks ago. Deep space, Sector J7739, a world NASA designated K2-18b, glowing with impossible chemistry. Oxygen, methane, water vapor, all in perfect balance, life's signature. But the star it orbits, dead for 3 billion years, a cold corpse drifting through the void. No light, no heat, no energy to sustain anything. Yet the planet thrives. And then the James Webb detected it. A repeating transmission, every 4.3 hours. Precise, mechanical, intentional. NASA's exobiology team went silent. Physicists called emergency meetings because this violates thermodynamics. It defies stellar evolution. It rewrites planetary science, a living world, orbiting death itself. And something is broadcasting into the dark, waiting. If life can exist where physics says it can't, what other cosmic laws are we breaking without knowing? September 11th, 2023, the James Webb Space Telescope locked onto K2-18b, a sub-Neptune world, 124 light-years from Earth, orbiting an M-dwarf star every 32.9 days, mass 8.9 Earths, radius 2.36 times our own. Scientists expected hydrogen, maybe methane, standard atmospheric readings for a planet in the habitable zone. What they found changed everything. Webb's near-infrared spectrograph pierced through 0.8 to 5.3 microns of atmospheric data. Carbon dioxide appeared first, then methane, blazing through the spectrum at 5 sigma confidence. Strong, clear, impossible to dismiss. But the carbon dioxide levels contradicted planetary formation models. Too much methane, not enough ammonia. The atmospheric chemistry pointed toward one conclusion: a hydrogen-rich envelope covering a vast liquid water ocean. A Hycean world, Earth-like temperature, alien structure. Then, the impossible signal emerged: dimethyl sulphide, DMS, a molecule Earth's oceans produce exclusively through biological processes, phytoplankton, marine microbes, life. The detection registered at 2 sigma. Weak, uncertain, but there. NASA stayed silent. No press release. The scientific community fractured. Some called it profound. Others demanded caution. The uncertainty hung in the data like static. April 16, 2025, Webb turned its instruments back toward K2-18b, different spectrograph. The team at Cambridge watched the data stream in, and the signal returned. Stronger, not just dimethyl sulphide this time, dimethyl disulphide, both molecules, same chemical family, both biological markers on Earth. The confidence level climbed past 2 sigma. The detection became undeniable. The signal came through strong and clear, lead researcher Niku Madhusudan confirmed. But K2-18b orbits at 0.1429 astronomical units from its host star, 40% of Mercury's distance from our Sun. The M-dwarf radiates 1,441 watts per square meter onto the planet's surface. Tidal locking forces one hemisphere into permanent daylight, the other into eternal night. Temperature differential, several hundred degrees Celsius. The day side blisters, the night side freezes. Physics says no life should survive this. Yet the biosignatures persist. At concentrations higher than Earth's own atmosphere, the atmospheric models break down when forced to explain it. Some researchers now question whether K2-18b is even a Hycean world at all. New interpretations suggest it might be a gas-rich mini-Neptune. No solid surface, no ocean. Just dense atmospheric layers producing chemistry that mimics biological processes. Laboratory experiments in 2024 demonstrated abiotic DMS formation under certain conditions. Comets contain it. Interstellar space contains it. Life is not the only explanation. But the signal repeats. The molecules cluster in specific spectral bands. And something about K2-18b's atmospheric composition defies every non-biological model NASA has tested. The Habitable Worlds Observatory won't launch until the 2040s. Until then, the data remains incomplete. The 99.7% confidence calculation circulating through exobiology circles comes from statistical modeling of the combined atmospheric signatures, not from confirmed detection mention of living organisms, just strong indication, overwhelming probability, mathematical certainty wrapped in cosmic mystery. Because beneath that hydrogen envelope, 124 light-years away, something is producing molecules Earth's biology creates on a world that shouldn't support life, under conditions that defy habitability models, and the Webb telescope keeps detecting it. Mission after mission, observation after observation, the chemistry doesn't lie. But what if the signal isn't coming from the atmosphere at all? 40 days later, the anomaly deepened. Webb's next observation run showed the spectral lines shifting. Not randomly, periodically, every 4.3 hours, the same cadence as the supposed DMS signature, but this time something else moved with it. A tiny wobble in K2-18b's transit, an invisible mass tugging at the planet. No moon, no ring system, no known object could explain it. ESA's Gaia data was pulled, cross-checked, the star's position jittered by micro-arc seconds, a gravitational fluctuation too precise to be noise. As if something with significant mass were adjusting its orbit in real time. The atmospheric models failed first, then the orbital models, then the magnetic field simulations collapsed under the strain of the new numbers. Because if something is synchronizing chemistry, gravity, and timing, down to the hour, the planet is no longer the only mystery. And if these two anomalies are not a coincidence, because now, every spectrum from K2-18b's transit is a question, not an answer. A shifting chemistry that moves like a heartbeat. A gravitational tremor that feels deliberate. Not proof of life, but proof that our models are smaller than the universe that built them. For a century, astronomy trusted patterns, stellar evolution, orbital mechanics, atmospheric equilibrium, rules that held from our moon to the edge of the observable cosmos. Yet a single distant world has begun to bend those lines, to blur the border between physics and intention. Maybe the signal is natural, maybe the orbit is unstable, maybe both are artifacts of a cosmos more complex than the equations written on human chalkboards. But somewhere, 124 light-years away, a hydrogen sky is carrying a message we do not yet know how to read. And as our telescopes sharpen, the universe is answering our questions with better mysteries. If one planet can challenge the laws we thought were universal, what else is waiting, unimagined, in the dark between the stars? Subscribe for more cosmic documentaries.